Right. Question one. It's about particles moving vertically on a straight line. It's a kinematics question. It says a particle is projected vertically upwards with a speed of u from point A, and A is 12 meters vertically above point B. So we need to draw a rough diagram. So since A is 12 meters vertically above B, we must mark the horizontal ground first, and that's B, and then you mark the 12 meters length. Let's call this 12 meters height, and this is where point A is, and this is point B, and A is projected upwards with a speed of u. So what happens is the particle goes on a projectile motion vertically and then goes to a maximum and comes back and eventually hits the ground. So this speed is u. Over here v is 0. Let's call this point C. We might need that point, we might not need that point, it doesn't matter. Just mark the highest point as point C, and then we also have that the particle moves freely under gravity until it hits the ground at B. So the time taken over here, it is t equals 0, and at this point t is equal to 4. So the total motion takes 4 seconds. Now they want you to find the value of u. So what we're going to do is we're going to consider the motion from A to B upwards. Why? Because initially the particle is moving upwards. So to avoid making mistakes, we must always write down the values with respect to the direction. Since we are applying the equation upwards, u is going to be same as u because we don't know the value of u. And then the acceleration is for the particle that's moving upwards initially is minus 9.8 because it was decelerating, and the time taken is going to be 4 seconds. And the displacement is very important. Displacement, we are applying the equation upwards, it ends up 12 meters below the starting point. If it goes 12 meters above, it should be towards AC direction, but it's the opposite direction. That's why I'm putting minus 12. And which equation can I use here? Probably S equals to ut plus half at squared. So S is minus 12 and we don't know u, so u times 4, using brackets to separate the terms. Then we got half minus 9.8, and again t square is 16. So you got to simplify this. So let's multiply half into 9.8 into 16, and that's going to be yep 78.4. So minus 12 equals to 4u minus 78.4. Bring the 78.4 to this side, so you will get minus 12, that's 66.4. 66.4 is equal to 4u. You divide it by 4 and you will get 16.6 exactly. So the initial speed u is 16.6 meters. Let's go back to the question. It now says find the speed when the particle hits the ground. Very simple. Apply the same equation from A to B. This time your velocity, we don't know, it should be a minus value because it is changing direction, and u towards upwards, which is 16.6. we just found that. Acceleration has no change, minus 9.8. we have the time, which is 4. If you want, you can use S equals to u plus v over 2 times t as well, right? So yeah, so S is minus 12. I'll use both the methods. So let's say we use v equals u plus 80. V is, we don't know, 16.6 plus minus 9.8 into 4. So 9.8 into 4, that's gonna be 39.2, which is 16.6 minus 39.2, and that gives you minus 22.6. However, they are asking for the speed, so speed has no negative value. So speed at B can say that is 22.6 meters per second. So this is where you get the 6 marks spread out. 3 marks for part A, 3 marks for part B. Alternatively, if someone wants to use the other method, I will say you can use S equals to U plus V over 2 times T minus 12, 16.6 plus V over 2 times 4. So minus 12 equal to 2 times 16.6 plus V minus 6 equals to 16.6 plus V. So V becomes minus 22.6. So speed at B once again is 22.6 meters per second. So we get the final answer.